We are starting a new unit this week, and it is about polynomials. It's really kind of a strange word, but it's a word that means a lot. We can add them, subtract them, multiply, and then when you get to Algebra 2, you will be learning to divide them. Now, many of the rules that we just learned and we had a test on, you're going to use again. So if you didn't do so well in the last unit, make sure that you are planning on coming in for tutoring this week and retaking as soon as possible by next Friday. All right, let's get started. Our first slide is the objectives for this lesson. We have a lot of things to cover. It's a lot of vocabulary words. You can choose to write them all down or just listen to me and let me tell you when the ones that you need to write down. Okay, the first thing we're going to do is classify polynomials. We're going to write them in standard form, evaluate expressions, and the last we're going to add and subtract polynomials. Now this is a lot of information, but it's really not that difficult. First of all, we have a monomial. A monomial is just a number or a variable or the multiplication of two numbers and variables with whole number exponents. That means you can't have any negative exponents. Let's look at a few of the things that are monomials. 5 is a monomial because it's a coefficient or it's a base. It's also a whole number. Now 5 would be considered 5x to the 0 power. X is also a monomial. It would be considered to the first power. Negative 7xy is also a monomial, and it's also to the first power. And 0.5x to the fourth is also a monomial. A monomial is a single term that has nothing added or subtracted to it. Now, not monomial is any negative exponent. You can't divide anything to have it be a monomial unless it's two numbers. 4x minus y has two terms, so that is not going to be a monomial. And 2 divided by x to the third, we are not going to do any division with monomials. Okay, the degree of the monomial is the sum of the exponents of the variables. Okay, let's look at the 5. This would have a degree of 0 because it doesn't have a variable. That is a constant, so it has a degree of 0. X to the first, the degree is going to be 1. You have to add the x and the y together. That degree would be 2. And the degree of the x is 4. All right, let's try a few of these. Okay, we have quite a few problems to write down, but they're pretty short when you work them. We have to find the degree of each monomial. Well, the degree, first of all, we have to add the exponents, which is the 4 and the 3 is 7. So the degree of this first problem is 7. What do you think about the second one? The e is to the first power. The d is to the first power. That makes a 2. So the degree is 2. Now, do you remember what we said about a constant? A constant has a power of 0. So the degree would be 0. Okay, remember that the terms of expression are the individual parts that being added or subtracted. That makes up the polynomial. A polynomial is a monomial or a sum or difference of monomials. Now, you do not have to write these down. You just have to kind of have an idea of what they are actually referring to. If you're the type of student that would like to write them down, go right ahead. The degree of the polynomial is the degree of the term with the greatest degree. So we've just practiced doing individual monomial degrees, and now we're going to do the degree of the entire polynomial. Okay, so here's number 4. We have to find the degree. So the first thing we have to do is find the degree of each term. 11x to the 7th, the degree is 7. 3x to the 3rd, the degree is 3. So the degree of the whole polynomial is the greatest, and so the answer is 7. Number 5, same exact thing. Find the degree of each term. The degree of w squared z has a degree of 3. The second one has a degree of 4. And the third term is x to the 0, so it has a degree of 0. The highest degree is going to be 4 for the whole entire polynomial. Okay, the terms of a polynomial may be written in any order. However, we math people like to put them in standard form. For standard form, you're going to start with the greatest degree and then go down to the smallest degree. And then the coefficient of the very, very first term is called the leading coefficient. Also, we put constants at the end. Okay, this is example 6. We have to write this in standard form, then give the leading coefficient. Our first thing to do is find the degree of each term. Then we're going to rearrange them. So the degree of the 6x is going to be 1. The degree of the 7x to the 5th is 5. The degree of the 4x squared is 2. And the 9 has a degree of 0. Okay, here they are written in standard form. The leading coefficient is going to be the -7 because it is in the front with the highest degree. Some polynomials have special names. Now this time you do need to pause this and write all of these down. Another idea would be to print this screen and tape it into your notes. This gets pretty long. Okay, a degree of 0 is constant. That is like the number 5 is a constant. Well, hello Zoe, my dog just joined me. All right, linear is x to the first power. It has a degree of 1 and it's considered linear. Quadratic has a degree of 2, so it's going to be x to the second power. That's called quadratic. Now remember, this is the highest degree. Cubic is x to the third. Quartic is x to the fourth. Quintic is x to the fifth. And any power, like let's say x to the 8th, that would be considered the 8th degree. Okay, now that is based on the highest degree. The second thing that we rank polynomials we talked about is the number of terms that they have. One term would be something like 5x squared. That is only one term, so it's considered a monomial. A binomial is if it has two terms, like 4x plus 2. We have two terms separated by a plus sign. The third one is a trinomial, and a trinomial has three terms. I'm going to bring this down, like x cubed plus 3x squared minus 2. This has three terms separated by plus and minus signs. Now anything 4 or more terms is going to be considered a polynomial. And you'll hear me call this is called name that nomial. All right, we're going to classify each polynomial according to the degree, which is going to be the highest degree, and the number of terms. Okay, and again, I'm going to call this name that nomial. Let's look at number 7. I see that there are two terms, one here and one here. That's two terms. Two terms is called a binomial. The highest degree is 3. And so that is going to be called a cubic binomial. We put the number of terms, the word that describes the number of terms first, and we put the highest degree first and then the number of terms second. Okay, number 8. The highest degree is going to be a 4. Now notice this is already put in standard form. Sometimes they may not be that way for you. The highest degree is 6. There are 1, 2, 3, 4 terms. So this is going to be called a 6th degree polynomial. Number 9 has one single term and the exponent is 1. So what would you call that? A degree of 1 is linear and the number of terms is monomial. So it's a linear monomial. Okay, now we're going to learn to add or subtract monomials. Oops. That shouldn't say monomials right here. Whoa, bad teacher. This should say polynomials, because we just switched over to polynomials. Okay, when we add and subtract polynomials, we have several things we need to do first. First, we need to make sure that we identify which terms are alike. So the only like terms that I see here are -6 and +8. I can put those together. I'm going to now this part I don't always do, okay, but you can do this part in your head. That would be to rearrange the whole thing so that the 8 and 6 are together. Y'all can probably skip that step and go straight to combining the like terms. So we have 5x squared is first, minus 3x is 7 is second, and 8 minus 6 is 2. Now, to name that nomial, it would be a quadratic trinomial because it has 3 terms. Now, you do have to know how to do this. All right, number 11, we are going to add and subtract. Pretend like this says not monomials, but polynomials. First thing to do is identify which are like terms. I see that they all have like terms because they all have m squared n. So I have 10 m squared n's. I have 4 m squared n's. That makes 14, and then I'm going to take away 8 m squared n's. Combining like terms, I just have a monomial. Add the exponents together. That's a third degree. Third degree is called a cubic monomial because there are no adding or subtracting signs separating any of the terms. Number 12, we are going to add polynomials now. And we're adding polynomials. We have to again first find the like terms. Now there's a plus sign in between here, so I really don't have anything to do but just put together the like terms. Okay, I found my like terms, 4m squared and m squared. That's going to add together to give me 5. Now this minus m does not have anything to add to it, so I would just write minus m, and then the 5 and the 6 are going to add to 11. Again, I'm going to write this step down, but you do not have to write that particular step down. And then combine terms, put them together, just like I said, 5m squared minus m plus 11. Now notice we're writing all of these in standard form, which means that you're starting with the highest exponent and going down, constants going at the end. This has a second degree. Second degrees are called quadratic. Since there are 3 terms, it's a quadratic trinomial. And let me just tell you, most of the things that we deal with, most of the polynomials we deal with in Algebra 1 are quadratic trinomials. Fun, huh? All right, 13, we are going to subtract polynomials. Now this time in the middle we have a minus sign. A plus sign I can just take off the parentheses and proceed, but the minus sign I'm actually going to have to work with. The first thing you're going to do is distribute this negative to each of them. Or you can just think of it as changing all of the signs to opposite. So minus 5m to the 4th, the negative times a negative is a positive, and negative times a positive is a negative. The next thing I need to do is identify which terms are alike. The 7m to the 4th and the negative 5m to the 4th are alike. The minus 2m squared and the plus 5m squared are like terms. And then this minus 8 is just going to go on the end by itself. Notice how I am circling the terms with the sign in front. Okay, again, I'm going to write this step down, but you do not have to write it down. You can just do that part in your head. And when we add 7m to the 4th, take away 5, that gives me 2. Negative 2m squared and 5m squared is positive 3m squared, and then the minus 8 goes on the end. Do you notice that each time I am not doing anything, to the terms that we're adding together? We're only adding the coefficient in the front. Another subtraction, once you pause, try this one and then turn it back on, and I'll be here waiting for you. Right, the first thing we need to do is distribute that negative. So a negative times an x squared makes a negative x squared, and negative times a negative 9 makes a positive sign. We need to identify our like terms. The 10x squared is like the negative 1x squared, which makes negative 11x squared. The negative 3x is going to be by itself, and the positive 7 and the positive 9 is going to add to 16. The part that you would do in your head. I put this in here because I wanted to show you. You can also add this vertically going down. It kind of looks like elimination. But notice the 10x squared and the negative 1x squared are lined up. The 7 and the 9 are like terms, so those are lined up. But the 3x is, I have to put a little placeholder here for the 0x because I can't put the 9 underneath the 3x. That's called using vertical addition. Okay, combining like terms going straight down, we have negative 11x squared minus 3x plus 16. Can you name that nomial? It is a quadratic trinomial. Okay, this is our last problem, number 15. These problems are really simple. A farmer has to add the areas of 2 plots of land to determine the amount of seed for the plant. To plant, the area of plot A is 3x squared plus 7x minus 5, and the area of plot B is 5x squared minus 4x plus 11. Now we have to do the total area, and it told us at the beginning we were going to add. So all you have to do here is write down what plot A is, and then write down what plot B. Notice I'm doing the vertical method again. And then all I'm going to do is combine like terms. So going down, these terms should add up to 8x squared, keeping the x squared the same. The 7 minus 4 would be 3x. And then negative 5 and 11 should be 6. So our final answer is going to be 8x squared plus 3x plus 6. Well, that's all for now, folks. Y'all have a great evening, and I will see you in the morning at 7 if you have any trouble. And plan on staying after school tomorrow if you have problems with your last test. Have a great weekend, guys. Bye-bye.